even on the quiz, but we did do this in Unit 1, and if it's on the review, there's a chance that it could be on the test. So first off, notice that these are not just limit questions. These are called infinite limit questions because they're only as x approaches infinity or negative infinity. So visually, as x approaches positive infinity or negative infinity, you're talking about the far extremes of the graph. So the first connection you need to make is that if you're talking about either the far right or far left of the graph, that is basically the same thing as horizontal asymptote. And then there's 3 rules for horizontal asymptotes. You have to compare the degree of the numerator to the degree of the denominator. When the degree of the numerator is bigger, it doesn't have a horizontal asymptote. That means it either goes to infinity or negative infinity, but we could say does not exist either way. When the denominator is bigger, it goes to 0. And the only other possibility is they're equal, and that's when you put leading coefficient over leading coefficient. So when I look at these, I don't really think of these as limit questions. I recognize this as, hey, this is just referring to the far left or far right of the graph, so they really just want me to do horizontal asymptote. So on A, since the degree of the denominator is bigger than the degree of the numerator, this is going to approach what? 0. Whether you're asked as x approaches infinity or x approaches negative infinity, it'd be 0 either way. Just using this horizontal asymptote rule. Okay, over here it looks like the degrees are equal, so that means that this function, the further you go to the right or the left, is going to get closer and closer to what? You say 5/7? Okay, that's correct. And then this one's just in multiple parts. So looking at everyone's work yesterday, this is the one that we, of course I didn't see y'all yesterday, it was my other class, but the limit of 4 is not 0. The derivative of 4 would be 0, but the limit of 4 is not 0. So if you don't remember that property, think about what 4 looks like as a graph. As you go to the far right or far left, it's always going to be 4. No matter what x value you're approaching, it's always approaching a y value of 4. Okay, what about from this little group? What is that going to come out to be? Okay. And then based on this group, what is all that going to go to? 0. So 4 minus a half would be 2.5 or 5/2. So basically horizontal asymptote rules, but you need to understand why it's horizontal asymptote rules for you to be able to do that. Actually, you know what? Let's, I've not shown this to you yet this year, but I think you're probably at the point where you might appreciate it now that you guys can do derivatives. There is also something called, and you will need to know this later on in the year, you don't have to know it right now, but it does help you with limits. There is something called L'Hopital's rule, where if you get indeterminate form, 0/0, or positive and negative infinity over positive or negative infinity, all of these are considered indeterminate forms. The first few weeks of school we talked about this one a lot, but this is also indeterminate form. So when I look at question A, if I just tried to plug in infinity, do you see how it goes to infinity on the top and infinity on the bottom? Number 1A. Okay, so if you forgot the horizontal asymptote rules, and this applies to all limits, you can actually use derivatives to help you with limit questions. This was part A. L'Hopital's rule says that if you get indeterminate form, any of these, you can take the derivative of the numerator, which would become what? Over the derivative of the denominator, which would become And then you can try direct substitution again. If it's still indeterminate form, you apply L'Hopital's rule again, derivative of the numerator over the derivative of the denominator. But this would not be indeterminate form anymore. If I try to plug infinity, if my numerator is stuck at 1 and my denominator just keeps getting bigger, what is that fraction going to? Okay, it's 1 over infinity, which is going to 0. Same answer we got on part A, right? So notice, I'll just do one more. This one's kind of silly to do L'Hopital's rule, but it's, I don't know, it doesn't hurt for you to see. If I tried to directly substitute infinity into all these x's, I would get infinity over infinity. So L'Hopital's rule says, well, why don't you take the derivative of the numerator over the derivative of the denominator and try again. If it's still indeterminate form, which this one is, you could do it again. Bring the power down, lower the power by 1. I don't know, 35 times 5 would be, what's that, 175?
Isn't it 42, not 37?
Oh yeah, that matters too. So that would be 210. Hold on, I lost. Oh, no I didn't. Okay, does that look okay? Okay, y'all are not confident either here, so let's just use calculator. Okay, those are fine. Unfortunately, this is still indeterminate form, infinity over infinity, so you could do L'Hopital's rule again. Again, I told you it was kind of silly to do it on this one, but oops. This is really not equal unless I have the limit out front. Still indeterminate form. So we could do the derivative again. Still indeterminate form. So derivative of the numerator again. Over the derivative of the denominator. It's still infinity over infinity. One more time. Okay, and then the derivative of a constant, just like we did the, the limit of a constant, just like part C, the limit of 4 is 4. The limit of this would be this, and this reduces to, what should it reduce to? And it does. So, I'm certainly not encouraging you to use L'Hopital's rule instead of the horizontal asymptote rules. I'm just showing you L'Hopital's rule a little bit early in case you ever want it for limit questions. Indeterminate form, derivative of the numerator, derivative of the denominator, try again. Still indeterminate form, do it again. Still indeterminate form, do it again. Eventually, you get it down to not being indeterminate form. And I would have shown you that at the start of the year, but you didn't know how to do derivatives at that time. So that's why we didn't learn that then.